In this video, we are going to do an integration review. The problems come from a Calculus 1 class. Number 1, evaluate the integral from 0 to 1 of x plus the square root of 1 minus x squared dx by interpreting it in terms of areas. The integral from 0 to 1 of x plus the square root of 1 minus x squared dx is equal to the integral from 0 to 1 of x dx plus the integral from 0 to 1 of the square root of 1 minus x squared dx. Now, we're going to take a look at these integrals individually. And we're going to do that on the next page and then circle back. So, for the first integral, I'm letting f of x equal x on the closed interval 0 to 1. And so notice when x is 0, f of 0 is 0, so you're at the origin. And when x is 1, f of 1 is 1, so you're at the point 1, 1. And so you get a line segment that connects 0, 0 to 1, 1. And what I'm going to do is I'm going to drop a perpendicular down. And if we interpret the integral in terms of areas, we're going to find the area of this right triangle. And if we look at the second integral, we're looking at the integral from 0 to 1 of the square root of 1 minus x squared. Well, that's a quarter circle, right? Notice how I let g of x equal the square root of 1 minus x squared on the interval 0 to 1. And so we're looking at a quarter circle, and I'm going to find the area of this shaded region. So in the first picture, we have a right triangle. The area of a right triangle is half the base times the height. Notice how the base is 1, the height is 1, okay? And in the second picture, we have a quarter of a circle. So we're looking at 1/4 the area of a circle, right? And the radius for this picture is 1. And so you might notice for the first integral, you're taking 1/2 the base times the height, so it's 1/2 of 1 times 1. And then in the second integral, it's a quarter circle, so it's 1/4 pi times the radius, which is 1 squared. And so the correct answer here is pi over 4 plus 1/2. And that's the answer to problem 1. On problem 2, if the integral from 0 to 6 of f of x dx is 10, and the integral from 0 to 4 of f of x dx is 7, find the integral from 4 to 6 of f of x dx. Now, mind you, I notice how I never told you what f of x is. Doesn't matter. We just know we can integrate whatever function it is. Now, it turns out that the integral from 0 to 4 of f of x dx plus the integral from 4 to 6 of f of x dx is equal to the integral from 0 to 6 of f of x dx. So you notice how I took the lower limit of the first integral and combined it with the upper limit of the second integral to get the integral on the other side. Now, we are given that the integral from 0 to 4 of f of x dx is 7. We don't know the integral from 4 to 6 of f of x dx. But we do know the integral from 0 to 6 of f of x dx is 10. And if I solve, I get the integral from 4 to 6 of f of x dx is equal to 3. Number 2. On number 3, we have the integral from negative 1 to 0 of x squared plus 5x dx. So the integral from negative 1 to 0 of x squared plus 5x dx is 1/3 x cubed plus 5 times 1/2 x squared, evaluated from negative 1 to 0. If I replace x with 0, I get 0. Then I go minus, and then I'm going to replace x with negative 1. And when I do, I get negative 1/3 plus 5/2. And so I'm going to distribute the negative inside to each term within the parentheses. And when I do, I get 1/3 minus 5/2. And so the correct answer here is negative 13/6. That's number 3. Let's take a look at number 4. This is the integral from 0 to 1 of 1 minus x to the 9th dx. So this is x minus 1/10 x to the 10th evaluated from 0 to 1. If I replace x with 1, I get 1 minus 1/10. And then keep in mind, when I replace x with 0, I get 0. So the correct answer here is 9/10. Now, be very careful, right? Notice the difference between number 4 and number 5. On number 5, I'm looking at the integral from 0 to 1 of 1 minus x all raised to the 9th power dx. You're not going to raise that to the 9th power. You don't want to do that. The classic way to attack this problem is u substitution. And so I'm going to let u equal 1 minus x. du is negative dx. Okay? And then it turns out that dx is negative du, right? Just moving the negative over to the other side. So when x is 0, u happens to be 1 because I'm plugging in up here. And when x is 1, u is 0. Well, we're in business. So the integral from 0 to 1 of 1 minus x to the 9th dx is negative the integral from 1 to 0 of u to the 9th du. But if I switch the limits, I change the sign of the integral. So from here to here, right, from first line to second line, notice how the limit switched. And when the limit switched, I changed the sign. So I'm integrating from 0 to 1 of u to the 9th du, which is 1/10 u to the 10th, evaluated from 0 to 1. The answer is 1/10. So it's a different tactic. They look a little similar, but it's definitely a different approach. Number 6. Suppose I have the integral from 1 to 9 of square root of u minus 2u squared divided by u du. And so what I'm going to do is split off that fraction. In other words, I'm going to take the integral from 1 to 9 of square root of u minus 2u squared over u du. And this is equal to the integral from 1 to 9 of square root of u over u minus 2u squared over u. But this is equal to the integral from 1 to 9 of 1 over the square root of u minus 2u du. Okay. Now, if we're not sure about that first term, square root of u is u to the 1/2. And I'm going to divide by u to the first, right? But by properties of exponents, this is u to the 1/2 minus 1. But 1/2 minus 1 is negative 1/2. And so this is u to the negative 1/2, which can be written as 1 over u to the 1/2. And so u to the 1/2 is the same as the square root of u. So we get the integral from 1 to 9 of 1 over the square root of u minus 2u du. And so we get 2 times the square root of u minus u squared evaluated from 1 to 9. Pop the 9 in. The square root of 9 is 3, okay? So we get 2 times 3 minus 9 squared minus, and then I'm going to pop the 1 in, and the square root of 1 is 1, and so you're subtracting 2 minus 1. But 2 minus 1 is 1. So I get 6 minus 81 minus 1, and if I add it up, I get negative 76. Or you can say subtract it up, right? So let's take a look at 7. Suppose we have the integral from 0 to 1 of y times y squared plus 1 to the 5th dy. This is classic U substitution. The inside function is y squared plus 1. And so I'm going to let u equal y squared plus 1. du is 2y dy. Y dy is 1/2 du. Okay, so I made my substitution. And so when y is 0, u is 1. When y is 1, u is 2. Okay, I'm plugging that information up here. And so the integral from 0 to 1 of y times y squared plus 1 to the 5th is 1/2 the integral from 1 to 2 of u to the 5th du, which is 1/2 times 1/6 u to the 6th evaluated from 1 to 2. And so I'm going to pull the 1/12 out in front, and I'm going to replace u with 2 and u with 1 and subtract those guys. And so I get 1/12 the quantity 2 to the 6th minus 1. Now, 2 to the 6th is 64. And so when I go to simplify, I get 63 over 12. And 63 over 12 reduces to 21 over 4. 21 over 4 is what I would be looking for if I was the instructor. So, number 8. Suppose we had the integral from 0 to 1 of v squared cosine of v cubed dv. So, again, another u substitution. I'm going to let u equal v to the 3rd. du is 3v squared dv. So, v squared dv, if I divide both sides by 3, you get, again, v squared dv is 1/3 du. Now, let's convert the v limits in terms of u limits. When v is 0, u is 0. When v is 1, u is 1. I'm plugging it into this equation here, u equals v cubed. That's how I'm getting my u limits, right here. So now I'm ready to make my substitution. The integral from 0 to 1 of v squared cosine of v cubed dv is 1/3 the integral from 0 to 1 of cosine u du, which is 1/3 sine of u evaluated from 0 to 1. So the correct answer here is 1/3 sine of 1. Number 9. This one's a great question because this is the integral from -1 to 1 of sine of x over 1 plus x squared dx. And in Calculus 1, you have a result that says something like the following. The integral from -a to a of f of x dx is equal to 0 if f is an odd function. Okay, and that's what I'm taking advantage of here. So I'm going to let f of x equals sine of x over 1 plus x squared, and I'm going to verify that f is indeed odd. So f of -x, I'm going to replace x with -x, and I'm going to get sine of -x divided by 1 plus -x quantity squared. But sine is an odd function. We know that from trigonometry. So we could write this as negative sine x divided by 1 plus x squared. And so down below, I have f of -x is equal to negative of sine of x over 1 plus x squared. But if you look up here, f of x is equal to sine of x over 1 plus x squared. So this is equal to negative f of x. Well, that says f is odd, and that tells me right away that the integral from -1 to 1 of sine of x over 1 plus x squared dx is indeed 0. Okay? That's number 9. If we take a look at number 10, we have the integral of x over x squared plus 1 dx. This is u substitution. I'm going to let u equal x squared plus 1. du is 2x dx. So x dx is 1/2 du. Okay? And so this is the integral of 1/u du with a 1/2 on the outside, right? So in other words, we have 1/2 the integral of 1/u du. So this is 1/2 natural log of the absolute value of u plus c, but u is x squared plus 1. So we get 1/2 natural log of x squared plus 1 plus c. And I don't need absolute value bars on the last line because x squared plus 1 is always positive, and I don't have to worry about taking the natural log of a negative number. I only have to have absolute value bars if there's a chance that you might have a negative value inside the natural log, if that makes sense. Okay. Number 11. Number 11 is fairly quick. Suppose we have the integral of 1/x squared plus 1 dx. The answer there is arctangent of x plus c, because we just happen to know that if I take the derivative of arctangent of x with respect to x, I absolutely will get 1/x squared plus 1. That's one you really need to recognize, especially going into calculus 2 and differential equations. It will come up repeatedly. If we take a look at number 12, number 12 is another good one. Suppose we have the integral of x plus 2 over square root of x squared plus 4x dx. This is a u substitution type problem. I'm going to let u equal x squared plus 4x. du is 2x plus 4 quantity dx. Factoring out the 2, you can see that du is 2 times the quantity x plus 2 dx. All right? And then I'm going to divide both sides by 2, and I'm going to say x plus 2 dx can be written as 1/2 du. And so on this line, we get 1/2 the integral of 1 over the square root of u du. And so this is 1/2 times 2 square root of u plus c. The 2's cancel, and I'm going to replace u with x squared plus 4x, so I can say that this is equal to square root of x squared plus 4x plus c. And that's how we do number 12. And let's just take a look at one more for this video. Suppose I give you the following. We'll call this number 13. Suppose I had sine of x times cosine of x dx. This is, again, a u substitution. The inside function is cosine x. So I'm going to let u be cosine of x. du is negative sine x dx. Okay? Sine of x dx is negative du. And so this is equal to negative the integral of cosine of u du. All right, and we're almost done. This is negative sine of u plus c. But u is cosine of x. So the correct answer here is negative sine of cosine of x plus c. And that'll do it for this video for this integration review. And this the 13 examples we did can be found in a Calculus 1 class. So these are at the Calculus 1 level. Okay, thank you.